All right, good morning, everyone. And thanks for being here. As Ben, Michelle, you couldn't set the stage better than you did. I really appreciate that. And I want to thank every single one of you because I know coming to Quebec, it's quite a ride. I know some of you had adventures at the airport yesterday. So I really appreciate the investment and the commitment to come here. And it was really important for me that all of you are here because, as Karine mentioned, we're going to start today a whole new chapter of the Robotiq story. And this story, it's all of our story. You're really front and center in that story. So let's see where it started. So I'll start with a little trivia. So whose hand is this? Anybody recognize this hand? Which hand? You're going to ask me, right? So the human hand is JP's hand. So JP was one of my two co-founders, as Karen mentioned, back in 2008. And the blue hand is a hand that he built during a summer internship. So at Laval University, it's about 15 minutes in that direction. And so we're three guys out of university who just wanted to do robotics. We knew robotics would become big soon, and we wanted to be part of it and have fun doing it. So we started the company, and we had access to technology that was great. Now we just needed to find customers, right? The easy part. So we took JP's prototype, and it was nice because it was a pneumatic gripper. So we could go to Walmart, buy a pneumatic, buy a compressed air bottle, the ones you use to actuate paintballs. So we could hook this up in the gripper and just drive around with our little suitcase and present this to different manufacturers. So we talked to several of them, and one of them was really visionary, and we really liked this guy. His name was Frank. And he was working for BRP, so Bombardier Recreational Products, which is a very important company here in Quebec because they invented the snowmobile. So Frank, he said, hey, I could use something like that because every time I need to do robotic cell, I need to do custom gripper, and it's trial and error in fabrication. And not only this, it will allow me to do mixed model manufacturing. So we have always changes in the line, and we always want to do one-piece flow and always have different models coming on the line. So having that flexibility will allow me to do this with my robots. So we said, great. And you know, because we really like this guy and we needed to start somewhere, that became our business plan in all innocence. So we went back working on the industrialization of this product. So as you see, this is a plastic version. So went back and spent about a year designing the first industrial version. And what's the next step? Obviously, you got a product, you got to go hit the road again and go sell this thing. So which road? Then the question was pretty easy because this was 2009. If you look at the data back then, you look at which companies are using robots, and it was pretty clear that automotive was still the biggest consumer. So we went to Michigan, and we went to sell our thing. So that's when we were learning how the industry was structured, and it's still mostly structured today. So we understood there were the robot manufacturers, people like us making grippers, some other things. And then there's that group of people, system integrators, who put all of this together and deploy this on the factory floor for their manufacturing customer. So luckily, the technology was intriguing enough. People wanted to see it. They wanted to. So it opened a lot of doors. We visited a lot of system integrators. The thing is, the conversation would always end pretty much the same way. It was some sort of a tank but no tank kind of ending, saying, hey, great product, cool technology, and I'm going to call you when I get a project. And there was no call back because there was no project, because the technology was not a right fit for the problem we're trying to solve. So after 6 months, I remember coming out of one of those meetings, and the road looked like the screen there. So there was freezing rain. I was just trying to make it safely back to the Detroit airport. And I was really puzzled. I was like, what's going on? So, and you got to remember the context as well. It was 2009. So anybody here was in the robotics industry in 2009? Yeah. So not the best year ever, right, for robots. So right after companies like GM crashed, so that sends a big ripple effect across the whole industry. So I was wondering, okay, is it because it's just not the right time? Is it because we're not trying hard enough? Or is it because these guys, they don't get it? Or is it me who's not getting something that I should be getting? So I was going with those questions in my mind, going back to Detroit airport. And And I finally made it to the airport safely, got on the regional jet. So you know how these jets are. You all took one or even a turboprop to come to Quebec City. So you sit in the plane and you get your pretzels and ginger ale and you're like this. You sit beside a tall guy and so you start talking with him. And it happened that this guy, his name was Neil, and he was working for Kamau. So Kamau is one of the biggest system integrators in the world. And they had a facility in Detroit, and he was coming here to present some projects to a local company. I said, wow, how lucky am I sitting beside this guy? So I started to talk to him, and as soon as I got the chance, I pulled out my iPhone 1 out of my pocket, not to show the iPhone, but to show the video I had. So, hey, look at this. Here's the gripper we're making. And Neil was really intrigued. He said, hey, I got a project right now. I have a customer. He needs to handle so many different parts. Why don't you come with your team and we can give it a try? We can do a proof of concept with this customer. So I said, sure, let's go back. And 3 weeks later, we're in Detroit and we're making this first robot hand work into an industrial robot. And here's the result. So yes, it was blue back then. That's one of the first versions. And that was really a great milestone for us, really a great pride. Okay, finally, we made it. We have some traction, and we have a gripper installed on an industrial robot. But it didn't last long. So as we thought there was some light at the end of the tunnel, Neil's project was canceled. That's one thing. That was obviously kind of a bummer. And the second thing is that I realized I had been lying all the way. So I had been selling this thing as a time saver, as a cost saver to many people. And it took 3 days to 3 super skilled engineers just to get the gripper communicate with the robot. So it was not plug and play at all. It was not time saving at all. So back to square one. But you know, when you start a business, selling is important, but getting the information is just as important as you start. And at that point, we had 2 very important pieces of information that would influence the course of the company up to what we're presenting today. So the first thing we realized is that we had a solution to a problem, and the fit was not good. So we're just trying to put a square into a round hole. That's the one thing. The second thing we realized is that custom tooling problem, you know, it's not such a big problem. It's not what's keeping the manufacturers at night, up at night. And what's preventing them to deploy more robots and to leverage more robots, it's not even the robot. The problem is this, is the robotic cell that's putting all the stuff together. So I told you, just having 2 devices to communicate took 3 days. This was before even programming the application and actually doing the application. And then you would walk in Kamau's open space, and you would see army of engineers, literally hundreds of engineers programming, simulating, designing robotic cell, and this was mind-boggling. I said, wow, that's a lot of work to get robots to work. So from then on, for every new product we would make, we had to use this insight. We had to make it easier every time for the manufacturer to put the systems together. So once we realized that, obviously, we reflected a lot. Why is it so complex? And there are a few reasons. The first reason is that, want it or not, we all look a little bit like this guy in industrial robotics. So you might have seen that image before, and if you look closely, you're going to see a lot of different devices that today all fit in your pocket and are much better than what's on the screen there. So there's no such thing as a standard in industrial robotics even today. And standards in industrial robotics, it's like toothbrush, right? Everybody say we got to be using one, but nobody wants to use somebody else's. And that's one big problem. So there's a rainbow of robots. Every robot comes with so many different communication protocols, and then each has its own software. And then you have everything that comes on the robotic cell. So that's a lot of work to make things work together. That's a lot of wasted time right there. And to that extent, I think what UR is doing with UR Plus is definitely a great step forward, because if you have the UR robot and you have the UR Plus components, well, you know you're going to be able to install them, you're going to be able to have the 2 things talk to each other, and you know you're going to be able to program them on the robot. So it's really a great step forward in solving that problem. But let's say we solve this problem, and in 5 years from now, everybody use the same standards in terms of communication, hardware, software. So we have the equivalent of, let's say, the USB of robotics, or the Windows, or the iOS, whether you're a PC or a Mac. Will it solve everything? And unfortunately, it won't solve everything. Because, robots, unlike computers, they deal with the real world. So computers, they're lucky. They deal with a perfect world of zeros and ones. But robots, they deal with the physical world. They deal with the real stuff. And we won't be able to standardize the real stuff. The real stuff is the stuff we use day in, day out, at our home, at our offices, at our company. So look at what this guy is doing, for instance. So he's using his eyes, tactile information, maybe even his ears, and understanding that process and doing this process and continuously assessing the quality of his job. That's something that today for robots is extremely difficult. So things for machines are super simple, like a computer can play 5 games of chess at the same time, which can be very difficult for a human. But the opposite is also true. Sensory motor skills are very intuitive for humans and are very difficult for robots still today. And until robots can really abstract the real world, it's going to be challenging. It's going to come back on the shoulder of the people putting the cell together to understand these processes and to automate it with robots. So it would be tough for a robot to do this, but it's also difficult for the people who need to conceive these robotic cells. Because to do this with a robot, first you got to understand what is the process. And how do you describe and capture all the information relevant to this process? It's really not obvious. So we're going to have to deal with this complexity of dealing with the physical world for quite some time, because robotic cells, they're not self-contained. Stuff come in, stuff come out. They interface with machines, with people. So what are our options today? What are the options of the manufacturers today? One option is say, I don't know anything about robots. I'm going to hire somebody outside of my company to come and do it for me. So you hire a system integrator, and for a fixed cost, they're going to come, they're going to do the design and the integration, and they're going to deliver for you a turnkey solution. And that's been the way of doing things for the last 50 years or so, and it will still prevail in many applications. But it has some drawbacks, and there are some new things, like new technologies like collaborative robots that are really changing the game. So one area where this approach is not well suited is when you have a high changeover, when you need to adapt your robotic cell all the time. So too many times we've seen people looking to go with robots. They said, I don't know robots enough, I'm going to go with a system integrator. Then they get the robotic cell, and this cell becomes a big monument in the middle of their factory floor. And anytime they introduce new parts, anytime they need to change their product or do continuous improvement, this monument cannot be moved, cannot be touched, cannot evolve. So that's a problem. The second problem is obviously the cost, and especially for the smaller projects. So a lot of the projects we see and that you guys see with our products, it's sell like 1, 2 robot cells. So let's say you have 1 robot cell, you buy the robot, you buy our products, maybe it's $70,000 worth of equipment. By the time the system integrator put all of it together, it might be $100,000, $150,000 to $150,000 cell. So for the end user, it's very difficult to justify the ROI for a single cell, a single robot cell. And not only this, even for the system integrator, considering the fact that they're going to need to manage this project from the outside, considering the risk of project, even if it's a small one, sometimes it's not even worth it for them. So there's kind of that no man's land right now where for the smaller projects, it doesn't work to go with system integrators. So we're seeing a lot of people being successful at doing it at the other end of the spectrum. So I'm a manufacturer, I'm capable, I got some engineering power, so we're going to learn how to use robots and we're going to do it on our own. And in fact, many of our successful customers, that's what they do. But they got to be aware that there are also some risks there. The biggest risk is it's a new technology. You don't know what you don't know yet. So you start the project, and because we all talked about the the skill shortage in manufacturing, everybody's running around. Everybody's spread too thin across all the things to do in the factory. Always emergencies going around, so I'm responsible for delivering that robotic cell project, but I need to run around and solve so many other things and keep so many other machines running. So what happens is that my project drags 1 month, 2 months longer, and then if it starts producing 2 months later, well, it's 2 months, it starts bringing back value 2 months later. So it's really bad for the ROI, and chances are, if it was longer, it's because you saw also some unexpected things, so it probably costs more also. So by combining these two things, the return on investment really goes down the ditch. So these are two options that we have right now. Neither are too ideal, so you might wonder, is there a third option? And unfortunately, there's one that we see too many manufacturers still take today. And the third option is the status quo. So I was preparing that presentation, searching on Google Image for status quo, and that's what I found. So maybe our friends from the UK, they know this band. It's a rock band from the UK. And I said, I got to use this image because just like the real status quo, they're rocking all over the world. And you know, status quo is an option until it's not an option anymore. And I think Michelle alluded to that in her talk. What are the reasons you started to look at robots at the beginning? So was it productivity issues? Are you trying to increase capacity? Do you have trouble finding the manual skilled worker? So do you think these problems will go away magically? In 5 years from now, your competitors will say, hey, let's give him a break, he's worked so hard, let's stop putting pressure on him so he reduces the cost of his manufacturing? Or do you think the young people will start rushing back to your factory floor, say, hey, I want to do that tough manual job that I didn't want to do for the past 5 years? This won't happen, right? And we all know this, and we're all too busy, and we all only deal with the urgent things instead of working on the important things. And our advice to manufacturers is escape the status quo as soon as possible, because these big, ugly problems are not going away. And the faster you get out of there, the faster you're going to create a competitive advantage around your robotics expertise. So here's what we're going to be working on at this event, and we need to work on this all together. So let's say it was less complex to deploy robotic cells. So whether you do it on your own or with external help, it would be more efficient to do it, so less costly. If it's less costly, you're going to have a better return on investment. And so much so, if it becomes so compelling, you're going to deploy more robots, and by deploying more robots, you're going to develop some skills internally in your factory. And what happens when you have more skills? It becomes less complex for you. And this really starts to run. So that's really the chain reaction that we all need to work on creating together. And that's really what this event is about. And you know, what's complex for me is not necessarily what's complex for you, and vice versa. So we're really lucky because we work with a lot of different manufacturers. And a lot of them make very interesting stuff. And one day I got a call from one manufacturer saying, hey Sam, would you mind coming to our place because we're thinking of introducing robots in our factory floor, and we'd like to know if it would work. And these guys, they build satellites. And I said, you bet, I want to see that for sure. Because that's what brought me in engineering. I wanted to do stuff that would go in space. And that's when, before I got lost into robotics and ended up on that stage this morning. So when they approached me and say, can you come check this out? I said, yeah, for sure. And when I got there, I realized that it was like any other factory, in fact. Yes, what they're doing is very special, very high-end knowledge, but it went the same way as any other manufacturer. So I got in there, talked to the managers and to the engineers. They explained why they want to use robots, and then we go walk the factory floor. So we go there, we stop at the first station, and then he explains the concept he has for a robotic cell there, and then he turns and say, hey, do you think I could put a robot there? And how can I put a robot there? So then we need to do a step back and try to forget the robot, look at the manual process to begin with, and then we discuss different options for putting a robot there. And then we keep walking the factory floor and go on the second station. And same question again. Can I put a robot there? How can I put a robot there? And same thing all across the factory. And that's when I realized, really, whether you build satellites or whether you're building staplers in New Jersey or electronic modules in China or valves in Europe, it's all the same questions. All the manufacturers have the same questions. And to deploy robotic cells successfully, you got to build that knowledge. So if you are to do it on your own, you have to have basic robotic skills. So designing the cell, programming the cell, optimizing it. You also have to build another skill set. That's robotics project management skills. So what are the steps to go between A, I have a manual process I want to automate, to Z, I got a working, productive robot. So what are the steps to go there? And the last skill set that you need, obviously, is the knowledge of your manufacturing process. And some manufacturers, they get into robotics, and sometimes they're intimidated. They say, oh, robots, it's high-tech, it's new, I'm not sure I can do it. But what they don't realize and what they really underestimate is that they got a critical piece of the information. They know, like nobody else, their manufacturing process, right? And not only they know it, but in the end, that's what's creating value for their customers. So that's really the most important piece of information. So how can they build the two other skill sets? How can they build the robotics skills, and how could they build the robotics project management skills? And where do they go to learn this? Do they go to college, or do they ask their suppliers, or do they ask system integrators? It's not clear. The answer is not out there. And not only this, because we have new technologies being introduced, and because we have a whole new way of looking at deploying robots, as has been mentioned, not that big top-down approach, not those big automotive body and white, like 40 type of robot, like projects that last for a year and a half. How do you deploy robots in that new bottom-up approach? So robot as a tool, I got a manual station there, I want to put a robot there. And there was nowhere to find this information. And that's why we decided to write a book that we're launching today. So that's the first thing we're announcing today. It's a book called Lean Robotics, and it's available. You can go on Amazon right now and buy it for all of your friends and uncles. But you don't need to. You're going to have a free copy this afternoon. So what this book is about? Well, this book, it's not the promotion of our products. It's really a book to show people how to deploy robots more effectively on their factory floor. And what it is really, it's the common wisdom, the common knowledge of all of you here in the room. So having the chance to deal with thousands of different manufacturers over the last decade or so, even if they do all sorts of different things. And you know, the only thing that doesn't change from one factory to another is that every factory is different, right? So you say, how can you have a standard process? Well, it happens that whatever you're building, the steps to deploy robotic cells are always pretty much the same. And that's what we put in this book. So you've seen these three words at a few places, right? It's in the program, it's on the wall, it's everywhere. And the core of the book is really this. So it's really a step-by-step guide. So for the people who say, how can I put a robot there that might look like a big fuzzy problem? Let's break it down into a set of small, clear, structured problems, and those three phases that might be obvious for many people in the robotics industry, but that we need to make explicit. And when you understand these steps, then it's easier to do, and then you can optimize also the different phases. So the design phase, we define it, is, okay, you got a manual process. The first thing is really mapping, getting the information on this manual process, coming up with some concepts, comparing both. And then you look at the ROI, you do your proof concept, you de-risk the project, you finalize the design, and you buy all this stuff. So that's the design phase. The integrate phase starts when you get all the material. So now it's a matter of putting it together, programming it, preparing the production line to receive the robotic cell, and optimizing it, and also training your people. And that's where you turn the key to on. And that's when the operate phase starts. So the operate phase is really, now you're not in an engineering project anymore. It's really, you're really in the production environment. And you know, we always talked about robotic system integration. And why we talk in the book about robotic cell deployment and not robotic integration is because the goal of this whole exercise is to have a productive robot in the end. So we need to include the operate phase in this whole process. That's really the end goal. So we gotta include it. So that's what you find in this book. And we call it lean robotics, so for many different reasons. Obviously, it's tied into the lean manufacturing approach. And I mentioned the lack of standard that's slowing all of us down. And the last thing we wanted to do was come up with a set of tools that would be disconnected with the tools that people already use. And lean is very pervasive in the manufacturing. And everybody understands the main ideas in lean. So the starting point, as Michel talked about, is who are your customers and what do they care about? How do they define value? And then you look at the different steps to produce that value, and then you eliminate the waste along the way. So the operate phase is clear for everyone, right? You got a robot on your factory floor. It needs to produce parts. That's pretty obvious. It's like anything else on your factory floor. But what people don't realize is the cost of all of this waste here. The waste in the design and integrate phases. And I've seen this so many times, and it's really killing me, and I really wanted to do something about it. Because let's take back the example that we had earlier. So you have $70,000 worth of equipment, and let's say once the robotic cell is being deployed, it's going to give you back $15,000 a month, just to give numbers. So what happens if your project is, you have delays of 1 month, 2 months? So 2 months times 15, it's $30,000 out of a $70,000 project. That's huge. That's a huge impact on the ROI. So what we want to do with lean robotics, first of all, obviously we want to have a great robotic cell, so the right cell for the right application. So once it starts operating, we want to make sure it keeps operating. So that means having the right design. So we give a lot of tips on how to do good designs, how to use good programming practices, for instance. So when it starts operating, it's really productive, and it stays productive. And the other thing we want to do is really this thing here. We want robots to start production earlier. And again, if you have one robot, that's already a big impact. And if you think of deploying 5, 10, or like some people in the room, they've deployed 30 robots, or they need to deploy 12 robots every year. So what is the impact for those guys? The financial impact is major if we can eliminate the waste in the design and integrate phase and put robots to production faster. So you didn't expect to come to a book launch, I guess, right? I'm sure you were hoping for some other things. And there are some other things coming up. And the first thing I want to point out is that, this methodology is really in continuity with all the products that we've been making. So all of you know our plug-and-play products, and the fact that they're flexible, that you can standardize and use them across many applications on your factory floor, and the fact that they're plug-and-play, so you don't waste time in installing them and programming them. It's really well aligned with the idea of that are presented in robotics. The other thing that most of you know also is a community that we launched a year ago, in fact, at the previous ROC. And DUF is really a thriving community, and it's really also another way to eliminate some waste, because one challenge is, as I mentioned, is putting the things together. And when you're putting the things together or you're programming your solution, you often stumble upon challenges. You have blockers. And if you block, you spend 1 day, 2 days, 3 days trying to get that answer. It's 3 days wasted. It's 3 days that your robot is not producing. So that's why we launched DUF. And DUF today has more than 1,000 users, and it has more than 300,000 views in the last year, and it's growing. We have new users joining every day. So these two things that we already do are very well aligned with the ideas presented in lean robotics. So let's say we want to take it further now. So we want to increase the efficiency starting at the design phase. So at the design phase, there are many things that are happening. And the design phase usually happens before the end user commits to buying the solution. And one big source of inefficiency in the design phase is just communication among different people. So we have end users located there, we have local partners, we have us here at Robotiq. We might need to interface with different vendors. And typical example would be, okay, we get an email from the website, customers say, I'd like to use your camera for such and such application. Do you think that could work? and then our ISS, our inside sales specialist, they reply and say, thanks for contacting us. Before I can answer your question, I have a few more questions. So what are the parts? How many parts? Size, weight, how are they presented, etc., etc. So by the time we can answer the initial question, again, it's been 2 weeks. And again, it's 2 weeks that your robot is not producing. So we want to streamline this. And that's why we're introducing blueprints also at the Rock. So blueprints, if you go on the website right now, you have buttons that says, what do you want to automate today? And if you click on this, you're going to end up on Blueprints, which is the web app that we're launching at the Rock. So what Blueprint, how it can improve the efficiency, the first way it's going to improve the efficiency is putting everybody on the same page. So instead of having a thread of email with one person, then having to go to that other person and retell the story again, all the story will be there in one blueprint. That's one thing. The second thing is that it is really structured according to the lean robotics methodology. And in the methodology, we explain step by step how to capture the information of a manual process. And you know, it's sometimes the biggest, one of the most common mistakes that I see is people start looking at the manual process and they are already thinking about the robot. So instead of understanding it, they talk about the robot right away. And we say, hold on a minute, we're going to get to the robot and it's going to be fun. For now, let's just focus on understanding the right process. So by having a standard way of presenting the information, and that's also another way to make sure we get all the information right at the beginning, because in robotic cell deployments, there's kind of a butterfly effect where some tiny details at the beginning can have huge impact in the end, and we want to capture those at the beginning. And the last way we remove friction in the communication at the design phase is by having the ability to go with your cell phone and take pictures and videos. So remember that guy who was polishing the glass. Again, how do you capture all this information? At this point in time, the easiest is still to take pictures and videos. So you go there and you complete the blueprint. So that's what blueprint is about, is really streamlining the efficiency in communicating in the design phase. Now, moving to the integrate phase. For some projects, the programming is a big chunk of the integrate time. And again, UR is a great simple interface, and we build UR caps for our products. And the UR cap, what they do is they provide you with the common functions for our product. So let's say the UR cap for our gripper, it's open and close. For the sensor, you get the raw data. So whatever application you're going to be doing, you're going to be using the UR caps. But what's happening, because we have integration coaches, and these guys, they get tons of questions every day, we see questions that come all the time. And we have 30 people in the last 40 days that ask the same question. They want to do this specific application with this specific plug-and-play component. Can we just build a small software module for them to speed programming time? And that's what Skills are about. So Skills is also a new product that we're launching here at The Rock. And what Skills are, they're really software add-ons that go on top of our plug-and-play components. So just to give you an example, so here's what a program looked like if you need to take a part and place it into a square fixture. So you pick that part, you want to make sure you go down, you're square in that direction, square in that direction, square in that direction. So to do this with the force torque sensor before Skills, you get the UR cap, you have program templates, and you do all this programming. So that takes a lot of time, and that can be a little daunting for some of the robot programmers who are just getting into robots. And here's what it becomes with Skills. So we have higher level functions, so really application-specific UR caps to really speed up the programming and ease up the programming of various applications. So Skills are also available today if you go on the website. We have a dozen right now, and you can download them and use them with our plug-and-play components to speed up programming. By the way, another announcement we have here at The Rock on the plug-and-play component side is that we have a major revision of our FT300 sensor. So this is our most popular model. That's the one that comes with the UR kits. And this major revision, what it is, it's a completely new revision of the electronics and a new way of calibrating them at the factory. In fact, we're using a UR robot to do it. It's pretty neat. So what 10x sensitivity means? Well, it means better active drive, better path recording, but also if you combine this increased sensitivity with the new skills, it's really going to open a breadth of applications in assembly and finishing mainly. So you're going to have the chance to see the force torque sensor later at the event also. So we do the design, we do the integration, and now it's the big day. We're starting our robot. And we've done everything possible to deploy a productive robotic cell as fast as possible. So that's when the operate phase starts. And then what? Then how productive was your robot? So we do all of these things. We do that big design project, and we take business risk, and we invest, and we buy all sorts of equipment, and then we start, and then what? We don't really know. So the whole goal of all that we did in the last 6 months was to have a productive robots, and we have no way of knowing how productive it is. And also, you know, robots, just like the other tools, they shouldn't be treated differently than anything else on your factory floor. Everything on the factory floor needs to be continuously improved. But then how can you improve something if you don't measure it? And that's why we're launching Insights. So Insights is the last breakthrough product we're introducing here at The Rock. And what Insights is about, it's a way to connect your robot over the cloud and to do a few different things. So the first thing is going to give you access. So Insights is really a freemium model. And the basic access, what it's going to give you is really you're going to know, okay, what's happening with my robot right now? Is it producing? Is it in an emergency stop? And what program is it running? The second tier is you're going to get alerts. And I mentioned earlier, in the operate phase, we want to eliminate all the downtimes. And we have many people here. We have people from Walt Machines, and these guys, they installed a robot, and the goal was to increase capacity. So the robot needs to be producing parts after working hours. So you want to make sure that it keeps producing, because if it doesn't keep producing, you cannot ship your order. So that's really critical. And with Insights, you're going to have alerts that tell you, hey, there's something wrong with the robot. Come and solve this problem. And the third tier that you're going to get with Insights is you're going to have a performance timeline. So when you're going to be able to look at past data and see what happened with my robot. So what were the programs that were run? Did I have emergency stops? Did I have some other stops? The productivity of the robot, the efficiency of the robot, et cetera, et cetera. So again, coming back to that idea of robots should be tools, they should be they should be seamlessly integrated on the factory floor. We should be able to continuously improve them. So with Insights, you're going to have actionable data you're going to be able to use to do your continuous improvement. So you need to increase capacity of your robotic cell, or you need to increase quality, et cetera. All of this actionable data is going to be available in Insights. You know, when you think about it, it's all about the return on investment, right? So all manufacturers, and you know, we are a manufacturer also, we invest in equipment, we want to get a return. And knowing the I part of the equation, that's pretty straightforward, right? You look at the invoice, you look at the quote, and you get the I, that's fine. What you're going to get with Insights now is the other part of the equation, which ideally would be much bigger and much more relevant for you. So you're going to have a clear understanding of what is the return. And not only you're going to have a good understanding, but you're going to be able to improve. So you're going to be able to continuously improve your robotic cell and increase your ROI as time goes. So to wrap it up, here's everything that we've just announced. And all these things are ready as of today. And you'll get your hands on all of these during the event. So the first thing is Blueprints, the web application to streamline communication in the robotic cell design phase. So for our plug-and-play components, we now have a new revision of the FT300 that's going to really enable a breadth of applications. And also to enable these applications and to do them faster, we're launching skills, so software add-ons, so application-specific UR caps for our plug-and-play components. DUF is still there. We're going to be using it during the event. And the cornerstone of the lean robotics approach is really insights. So again, all of these things that we're doing, it all converge at one single point. And this point is, I got a working productive robot on my factory floor. And insight's going to be right there, measuring what is the impact of all of the work that you've done. So taken individually, all of these products have some merit, but the real goal is really to make it flow, is really to go from design to integrate and to operate as smoothly and go through these phases in a breeze. So it's going to be better for everybody, and we're going to have more productive robots. So that's almost the end of my talk, and soon you're going to be more in action. So I want to tell you a little bit what you can expect next. So next, Karen will tell you the detail about launch and the logistics of the day. And this afternoon we have 3 workshops. So we have the design, the integrate, the operate workshop, and in each of these workshops, you're going to see what is the lean robotics method about, and how the Robotiq products can be used to support this method. So that's what's going to happen this afternoon. Now, this evening, we'll go to Chateau Frontenac, which is a very nice hotel in the old part of town, and it's going to be good fun and good food for sure. And when you're going to be there, you're going to have a preview of the technical challenge. And so really to raise the intensity a little bit, you're going to see this tonight. And if you look on your badge, there are some numbers you might have noticed already. So for those who have numbers, that means you are in a team. And tonight, try to find those people who have the same number as you, and try to start building that team spirit, because tomorrow is going to be really a team challenge. And even if you work really hard on the team spirit tonight, because it can be tempting in old Quebec, make sure to be here on time at 8:30 tomorrow morning. I won't be on stage. Etienne will be. Etienne, our Director of Tech Support, and Etienne's going to explain to you all the details of the challenge. And you know, we start here, everybody together, the technical, the commercial track, and then those 3 doors, the design, integrate, operate doors will open, and on the other side of the door, you have 40 production-hungry universal robots, fully equipped with the full stack of Robotiq products. And then the technical people will be working on producing actual parts over there, and the commercial team, we're going to have some training, and also we're going to have a friendly sales pitch competition. So that's what's coming up next at the Rock. And it's called a challenge because it's going to be a challenge. It's going to be tough. And you know, we're really pushing our limits in this event, and we're pushing the limits of the whole industry. And you know, before today, so before UR Plus, before the variety of plug-and-play components, blueprints, insights, DUF, and the skills, before all of that, and most importantly, before putting in one place all this collaborative robots expertise, before putting all these conditions together, such an event would not be possible. So to my knowledge, it's the first time such an event is being held. So it's going to be really exciting. I'm sure you got a lot of questions. Many of them will be answered in the workshop this afternoon. And I hope you have a good time, and I hope you have a great Rock. Thanks, everyone.